Good morning. Myself, Shekhar from Government Polytechnic College Sikar. Today in this lecture, we will derive the E.M.F equation of DC generator. Means the equation for voltage generated by the DC generator. In DC generator, when the field winding, when current flows through the field winding, then it produces magnetic flux phi. And in this magnetic flux phi, when a conductor is rotated, then flux is cut by the armature conductor and an E.M.F is induced in the armature conductor. Let phi is value of flux under one pole. Value of flux under one pole. Flux per pole. The unit of flux is Weber. So, in Weber. Z is total number of armature conductors. Total number of armature conductors. N is the speed of rotor in RPM, revolutions per minute. Speed in RPM, revolutions per minute. P is number of field poles. Number of field poles on the yoke. Number of field poles. A is number of parallel paths. Number of parallel paths. Then average value of E.M.F. Average value of E.M.F. induced in one conductor when it completes one rotation. Average value of E.M.F. induced in one conductor when it completes one rotation. When the armature conductor passes under one pole, then flux cut by armature conductor is phi Weber. When it passes under the second pole, then again phi flux is cut. When it passes under the third pole, again phi flux is cut, and so on. So, if the total number of poles is P, then the total flux cut by the armature conductor in a one rotation will be P phi Weber. Will be P phi Weber. Now, time required to complete one rotation. Time required to complete one rotation. Speed of rotor is n RPM. Means the armature conductor or armature completes n rotations in 60 minutes. So time for one rotation will be 60 upon n second. 60 upon n second. So the average value of E.M.F. induced in one conductor is given by d phi by dt. d phi by dt. average value of induced EMF for conductor is equal to d phi by dt, and this is equal to d phi value of change in flux or flux cut by one conductor in one rotation is d phi by 1, and time for one rotation is 60 upon n, and this is equal to p phi n upon 60 E average per conductor. So this relation gives the value of average value of EMF induced in one conductor in one rotation. Now in armature, total number of conductors is Z, and these Z conductors are divided into a parallel path. Number of parallel path is A. So number of conductor in one parallel path will be Z upon A. Number of armature conductors in one parallel path will be Z upon A. Hence, the average value of EMF induced per path, E average per path is equal to P phi n upon 60 multiplied by number of conductors in one parallel path, and this is Z upon A. So this equation gives the average value of EMF, average value of induced EMF across one parallel path, and this value of E average per path will be equal to the average value of or output voltage of voltage generated by DC generator. So average value of generated voltage is equal to phi Z and P upon 60A. This equation is called EMF, equation of DC generator. EMF equation of DC generator. Equation number first. Here A is number of parallel path, and number of parallel path depends upon the type of winding. So case first for lap winding. In lap winding, number of parallel path is equal to number of poles. If the DC generator have lap type winding, then number of parallel paths will be equal to number of poles. Then the average value of generated voltage is given by and this is equal to volt. Case second for wave winding. If the armature have wave type winding, then for wave winding number of parallel path is 2. Number of parallel path is 2, and for this winding the average value of generated voltage is given by E is equal to volt. We can mark this as equation number second and this as equation number third. So equation number first is general equation of voltage generated by DC generator or EMF equation of DC generator. This is second equation gives the value of generated voltage for lap winding, and this equation gives the value of generated voltage when the armature have wave type winding. Wave type winding. Now take a numerical problem for voltage generated by a DC generator. The wave wound armature is wave wound, means number of parallel path is 2. Armature of a 4 pole. Number of poles is 4 and armature is wave wound. Generator has 51 slots. Number of slots is 51. Each slot containing 12 conductors. Number of conductors in one slot is 12. If the flux per pole is 7.5 into 10 to the power minus 3 Weber, flux under one pole is 7.5 into 10 to the power minus 3 Weber. What will be the induced EMF at 1500 RPM? What will be the value of induced EMF at 1500 RPM? So speed of rotor is 1500 RPM. Means the rotor completes 1500 rotations in 1 minute. First, we will note the various given parameters. So, given parameters are number of parallel path is 2. Armature is wave wound. Number of poles P is 4. P is equal to 4. Number of slots 51 and conductors per slot is 12. So total number of conductors is number of slots multiplied with number of conductors per slot. Z is equal to this. Flux per pole is 7.5 into 10 to the power minus 3 Weber, and speed N is 1500 RPM. 1500 RPM. Now, from these given parameters, then value of generated voltage is equal to 5 Z N P upon 68. Substituting the value of various parameters, value of generated voltage, value of 5 is 725 into 10 to the power minus 3. Number of conductors 51 into 12. Speed 1500 and number of poles is 4 and 60 into number of parallel path. Number of parallel path is 2. And solving this equation, the value of voltage generated by the DC generator is equal to solving this equation, the value of generated voltage is 234.8 volt. Thank you.